Hi guys, welcome to enginerdmath channel. So we're live. Our topic is solving systems of linear equations, which is part 2. So I already have part 1 for this topic, solving systems of linear equations, wherein we just solve systems of linear equations in two unknowns, let's say x and y, using substitution and elimination method. Now, let's have this system of linear equations with three unknowns. So let's try to solve some problems. For the first one, we have negative x plus y minus z equals 0, 2y plus z equals 3, and 1 half z equals 0. So we now have three linear equations in three unknowns, x, y, and z. So let's name the first one as our equation 1, the second as equation 2, and the third as equation 3. So obviously, in the third equation, we can already solve for z, right? So we can multiply both sides of equation 3 by 2 to eliminate the coefficient of z, which is 1 half. So multiplying both sides of equation 3 by 2. So 2 times 1 half z, we can cancel out this 2. We now have z equal to 0 times 2 or 0. So therefore, the value of z is 0. From equation 2, we can substitute this obtained value of z to solve for y. So substitute z equals 0 in 2. So equation 2 is 2y plus z equals 3. But z is equal to 0. Substitute, we have 2y plus 0 is equal to 3. Therefore, 2y is just equal to 3. Then to solve for y, we divide both sides by 2 so that y is equal to 3 over 2 or 3 halves. Lastly, for using equation 1, we can solve for x if we substitute the value of z0 and y is equal to 3 halves. So equation 1 is negative x plus y minus z equals 0. So from 1, negative x plus y minus z is 0. Substitute the value of y and z. So negative x plus y is 3 halves minus z, which is 0, equal to 0. So therefore, it's just negative x plus 3 halves equal to 0. Then we can transpose this negative x to the right side. Therefore, we have 3 halves is equal to positive x, or x is equal to 3 halves. So the solution for the system of linear equation is x is 3 halves, y is 3 halves, and z is 0. Or in x, comma y, comma z coordinate form, we have 3 halves, comma 3 halves, comma 0. Okay, next for problem number 2. What if we have x plus y plus z equals 6, 2x minus y plus z equals 3, 3x minus z equals 0. Okay, so let's name the first equation as equation 1, second as equation 2, and third as equation 3. So this time, what we can do is, okay, using equation 3, let's try to solve for x. Let's try to solve for z, I mean in terms of x, right? Because it only involves x and z variable. So from equation 3, we solve for z in terms of x. you just transpose z to the right side so that you have 3x is equal to z. So let's name this equation 4. Okay? Now, the goal is to get two equations into unknowns only. Let's say, reduce this equation 1 and equation 2 in terms of two unknowns x and y. Okay? Meaning, we should eliminate the z, right? Because we have values of z in terms of x in equation 4, we can substitute this value of z in 1 and in 2 so that equation 1 and 2 will become in terms of x and y only as the goal. Okay? So substitute 4 in 1. So equation 1 is x plus y plus z, wherein z in terms of x is 3x, so you can substitute that, equal to 6. So simplifying, we have x plus 3x, that will be 4x, then plus y equals 6. So let's name this equation 5. Also, substitute 4 in 2. So equation 2 is 2x minus y plus z equals 3. 2x minus y plus z. Again, substitute z in terms of x, which is 3x, then equal to 3. Simplifying this, we have 2x minus y plus 3x. You can combine 2x plus 3x. So that will be 5x minus y equals 3. Let's name this equation 6. Now, using equation 5 and 6, so equation 5 is 4x plus y equals 6. And equation 6 is 5x minus y equals 3. So this is 5, this is 6. We now have system of linear equations only in two unknowns. So we can apply what we've learned on my previous lesson in this topic also, solving system of linear equations. So notice that the coefficient of y here in equation 5 and 6 are additive inverse of each other. In equation 5, the coefficient of y is positive 1. And in equation 6, the coefficient of y is negative 1. So we can apply elimination method. We can just add uh, the two equations in order for us to eliminate the y. Okay? So that 5 plus 6, you can add 5 and 6 to eliminate the y. 4x plus 1y equals 6, or you don't need to actually put the 1. I just show it to you because the coefficient of y is invisible 1. 4x plus y equals 6 and 5x minus y equals 3. If you add them, 4x plus 5x, that's 9x. Then y plus negative y, so that's 0. We already eliminated the y. And then for the right side, we add 6 plus 3, which is 9. So to solve for x, we just divide both sides of the equation by 9. Therefore, x is equal to 9 divided by 9, or 1. Now that we have the value of x equal to 1, we can use any of equation 5 or 6 to solve for y. So let's just use equation, or actually we can solve for z first, right? Because it's easier to solve for z. It's just in terms of x, because z is equal to 3x, and we also already got the value of x, which is 1. So from 4, z is equal to 3x, but we already got the value of x, which is 1. So substitute here. We have z is equal to 3 times 1, or 3. So z is equal to 3. And finally, to solve for y, we can use equation 1, substitute the value of x and z that we got. Let me copy equation 1. So substitute the value of x, which is 1, plus y, unknown, plus z, the value that we got is 3, substitute, equal to 6. So 1 plus 3, that will be 4, plus y equals 6. So transpose this 4 to the right side. Y is equal to 6 minus 4, or y is equal to 2. So therefore, the solution for the system of equation is x is equal to 1, y is equal to 2, and z is equal to 3. Or the coordinate 1, comma 2, comma 3. Okay, next, number 3. 2x plus y plus 2z equals 3. 3x plus 2y plus z equals 1. And x plus 3y plus 4z equals 10. So let's name this equation 1, equation 2, equation 3. Okay, so just like what we did on previous problem, we eliminate one variable first so that we will have two equations in two unknowns. So it's up to us what variable to eliminate first. You can eliminate first x, y, or z. So if you want to eliminate the z variable first, okay, so using equation 1 and 2, I can eliminate z by, so you can either make the coefficient of z in equation 1 and equation 2 have the same coefficient, or the coefficient can be additive inverse of each other. So if I multiply equation 2, okay, by negative 2, it will become additive inverse of each other for the coefficients of z. So doing that, negative 2 times 2, okay, multiply both sides of the equation 2 by negative 2, 3x plus 2y plus z equals 1. Distribute this negative 2. Negative 2 times 3x, negative 6x. Negative 2 times 2y, negative 4y. Negative 2 times z, negative 2z equals negative 2 times 1, negative 2. Let's name this equation 4. And then, we can now add equation 1 and 4 to eliminate the z because the coefficients are now additive inverse of each other, 2 and negative 2. So add equation 1 plus 4. Equation 1 is 2x plus y plus 2z equals 3. We add this with equation 4, negative 6x minus 4y minus 2z equals negative 2. So 2x plus negative 6x, that's negative 4x. Okay. And then y plus negative 4y, that's negative 3y. Then 2z plus negative 2z, 0. So we already eliminated the z variable. Then on the right side, we have 3 plus negative 2, positive 1. So let's name this equation 5. Okay. Now, let's eliminate again z using equation 2 and 3 this time. So I will make the coefficient of z in equation 2 additive inverse of the coefficient of z in equation 3, which is 4. So I will multiply equation 2 both sides by negative 4, right? So multiply negative 4 times equation 2. So multiply both sides of equation 2, 3x plus 2y plus z equals 1 by negative 4. So distribute this negative 4. Negative 4 times 3x, that's negative 12x. Negative 4 times 2y, that's negative 8y. And negative 4 times z, that's negative 4z. Negative 4 times 1, it's negative 4. Let's name this equation 6. So we can now add equation 6 and 3 to eliminate the variable z. So if we add 6 plus 3, so equation 6 is this, negative 12x minus 8y minus 4z equals negative 4, plus equation 3 is x plus 3y plus 4z equals 10. X plus 3y plus 4z equals 10. So negative 12x plus x, that's negative 11x. Negative 8y plus 3y, that's negative 5y. And then negative 4z plus 4z, so 0. We already eliminated variable z. Equal to negative 4 plus 10, positive 6. So let's name this equation 7. Okay. Now, we can use equation 5 and 7. So, equation 5 is negative 4x minus 3y equals 1. And equation 7 is negative 11x minus 5y equals 6. So, we now have two equations in two unknowns. Okay? So, we can use elimination method again if we want to solve for y. Okay? We can eliminate x first by, okay, if we multiply equation 5 by 11 and multiply equation 7 by 4, then subtract the two equations, we can eliminate the x. So what we will do is multiply equation 5 by 4, by 11, then minus, okay, 4 times or multiply equation 7 by negative 4, and then add 11 times equation 5 plus negative 4 times equation 7. So, multiplying equation 5 by 11 first, so negative 4x minus 3y equals 1. Distribute this 11. So, 11 times negative 4x, that's negative 44x. 11 times negative 3y, that's negative 33y. Then, 11 times 1, that's 11. Okay? And then for equation 7, okay, we multiply negative 4 both sides. So negative 11x minus 5y equals 6. Distribute this negative 4. So negative 4 times negative 11x, positive 44x. Negative 4 times negative 5y, positive 20y. Then negative 4 times 6, negative 24. So if we add this equation, copy, with this equation, we can eliminate the x. So 44x plus negative 44x, so 0x. We already eliminated the x variable. Then for y, 20y plus negative 33y, that's negative 13y, right? Then for the constants on the right side, negative 24 plus 11, that's negative 13. So if we divide both sides by negative 13, we have the value of y equal to negative 13 over negative 13 or positive 1. Okay, now that we have the value of y, we can use either, going back, we can use either equation 5 or 7 to solve for x. So let's use equation 5. From 5, which is negative 4x minus 3y equals 1. We can substitute y is equal to 1 here to solve for x. So negative 4x minus 3 times y, which is 1, equals 1. So negative 4x minus 3 times 1 is 3, equal to 1. Transpose this negative 3x to the right side. Negative 4x is equal to 1 plus 3. Or negative 4x is equal to 1 plus 3, or 4. Then dividing both sides by negative 4, x is equal to 4 over negative 4, or negative 1. Finally, we can solve for z using any of that first three equation. So let's use equation 2. Copy. Then plug in here the value of x, negative 1, and the value of y, 1, to solve for z. So 3 times x, which is negative 1, plus 2 times y, which is 1, plus z equals 1. So 3 times negative 1, that's negative 3, plus 2 times 1, 2, plus z equals 1. Negative 3 plus 2, negative 1, plus z equals 1. Transposing negative 1 to the right, we have z is equal to 1 plus 1. Therefore, z is equal to 1 plus 1, or 2. So the solution for this system of linear equation is x is negative 1, y is 1, and z is 2, or the coordinate negative 1, comma 1, comma 2. Okay, next problem number 4. What if we have 2 over x plus 3 over y plus 4 over z equals 11, negative 3 over x plus 2 over y minus 2 over z equals negative 11, and 4 over x minus 5 over y plus 3 over z equals 18. Okay, let's name this equation 1, equation, or not yet, because this is actually not linear system of linear equations, because notice that the variables are under the denominator, the x, y, z. So this is not a linear, this is system of linear equations. But we can transform this into system of linear equations by introducing a substitution. Let's say if we let a be equal to 1 over x, let b be equal to 1 over y, and let c be equal to 1 over z. So this equation, the first one, can be written as 2 times 1 over x plus 3 times 1 over y plus 4 times 1 over z equals 11. Or applying this substitution, this will become 2 times 1 over x is a, plus 3, 1 over y is b, plus 4, 1 over c equals 11. So this becomes linear equation in ABC. Applying the same substitution in the second one, so we have negative 3 times, so it's the same as 1 over x, plus 2 times 1 over y, minus 2 times 1 over z equals negative 11. Or negative 3a plus 2b plus, minus 2c equals negative 11. Then for the last, or the third equation, it can be written as 4 times 1 over x minus 5 times 1 over y plus 3 times 1 over z equals 18. Or using the substitution, this will be 4a minus 5b plus 3c equals 18. So gathering these three equations, we have the first one, copy. The second one, copy. The third one, copy. So we have transformed the system of nonlinear equations into system of linear equations in three unknowns A, B, C. So we try to solve this first, and then once we have the value of A, B, and C, we solve the original variable x, y, and z by solving these three equations when we already have the value of A, B, and C for x, y, and z respectively. So let's now name this as equation 1, this as equation 2, and this as equation 3. Okay. So, three systems of linear equations or three linear equations in three unknowns. Just like what we did, we try to eliminate one variable at a time. If we want to eliminate, let's say, C first, eliminate C first. Okay, so using equation 1 and 2, you can add equation 1 plus 2 times equation 2 if you want to eliminate the C so that the coefficient of C in 1 and 2 are additive inverse of each other, right? Which are 4 and negative 4, right? So equation 1 is 2a plus 3b plus 4c equals 11. And 2 times equation 2. So multiply equation 2 both sides by 2. So 2 times quantity negative 3a plus 2b minus 2c equals negative 11. So distribute this 2. 2 times negative 3a negative 6a. 2 times 2b positive 4b. 2 times negative 2c negative 4c. 2 times negative 11 negative 22. So you can now add equation 1 here. So negative 6a plus 2a negative 4a, 4b plus 3b, 7b positive. The negative 4c plus 4c, 0, cancel. The negative 22 plus 11, negative 11. So let's name this equation 4. Next, we need to eliminate again C, this time by using equation, let's try 2 and 3. Okay. So we can multiply equation 2 by 3 and multiply equation 3 by 2 so that the coefficients of C in equation 2 and 3 are additive inverse of each other, which are negative 6 and positive 6. So you can add the resulting equation to eliminate the C. Okay, so what we will do is 3 times equation 2 plus 2 times equation 3. So multiply both sides of equation 2, this one copy, by 3. So distribute this 3. 3 times negative 3a negative 9a. 3 times 2b positive 6b. 3 times negative 2c negative 6c. 3 times negative 11 negative 33. Also, multiply 2 times equation 3, this one, copy. So distribute this 2. 2 times 4a, 8a. 2 times negative 5b, negative 10b. 2 times 3c, positive 6c. 2 times 18, 36. So we can now add these two equations to eliminate C. So 8a plus negative 9a, that's negative 1a or negative a. Negative 10b plus 6b, negative 4b. And 6c, positive 6c plus negative 6c, 0. Cancel out. Then 36 plus negative 33, positive 3. Okay, so let's name this equation 5. So using equation 4, this one, okay, and equation 5, we can now eliminate, let's say, A, right? Eliminate A by, if we multiply 4 or negative 4 times equation 5, and we add this with equation 4, we can eliminate the A. So negative 4 times equation 5, negative A minus 4B equals 3. Distribute this negative 4. Negative 4 times negative A, positive 4A. Negative 4 times negative 4B, positive 16B. And then um, equal to negative 4 times 3, negative 12. And then if we add now equation 4, so 4a plus negative 4a, 0a. So we already eliminated the a as our goal. Then 16b plus 7b, that's 23b. And negative 12 plus negative 11, negative 23. Therefore, to solve for b, just divide both sets by 23. So b is equal to negative 23 over 23, or negative 1. Now that we have the value of b equal to negative 1, we can use equation 5 or 4, right, to solve for a. If we just use the easier equation to solve for a is equation 5. So from 5, which is negative a minus 4b equals 3, substitute the value of b that we have, negative 1. So negative a minus 4 times b, negative 1, equals 3. So negative a minus 4 times negative 1, positive 4, equals 3. You can transpose this 4 to the right side. So negative a is equal to 3 minus 4. Or negative a is 3 minus 4, negative 1. So divide both sides by negative 1 to eliminate the coefficient of a, which is negative 1. So a is negative 1 over negative 1, which is positive 1. Finally, we can solve for c. Now that we have a is 1 and b is negative 1, we can use any of the first three equations. Let's try to use equation 1, copy. Okay. Substitute the value of a, which is 1. So 2 times a, 1, plus 3b. Substitute the value that we got, negative 1, plus 4c, the unknown, equal to 11. So 2 times 1, that's 2, plus 3 times negative 1, negative 3, plus 4c equals 11. 2 plus negative 3, negative 1, plus 4c equals 11. Transpose this negative 1 to the right side. 4c is 11 plus 1, or 4c is equal to 12. Then divide both sides by 4, so that we can solve for c equal to 12 over 4, or 3. Now, this is not the final answer because the original variables are x, y, and z. So if we use the substitution, a is equal to 1 over x, b is equal to 1 over y, c is equal to 1 over z. This is the one that we use on the above here. right? So we substitute the value of a, b, and c that we got. For a is equal to 1 over x, the value of a is 1. So we have 1 is equal to 1 over x. So to solve for x, we multiply both sides of the equation by the denominator x. So x times 1 is x. Then 1 over x times x, cancel the x is 1. For b, the value is negative 1. So substitute here, negative 1 is 1 over y. Again, multiply both sides by y to solve for y. Y times negative 1, negative y. And 1 over y times y. Cancel the y, it's 1. And then eliminate the coefficient of y, which is negative 1. Divide both sides by negative 1. So that y is 1 over negative 1 or negative 1. Then lastly, for c, substitute the value. We got 3 equal to 1 over z. So multiply both sides by z. So z times 3 or 3z is equal to 1 over z times z. Cancelling out the z, we have 1. Then solve for c by dividing both sides by 3. Therefore, z is equal to 1/3. So therefore, the solution for the system of equation is that x is 1, y is negative 1, and z is 1/3. Or the coordinate 1, comma, negative 1, comma, 1/3. Okay? Next, number 5. Okay, what if we have 5x plus 2y plus z equals 0, 2x plus y equals 0. Okay, this time, we have three unknowns, x, y, z, right? But the equations that we have are only two. So the equation is less, excuse me. So the number of equations is less than the number of unknowns. So this means that we can have infinitely many solutions. Okay? So to solve for the parametric set of solution here, let's name this equation 1. Let's name this equation 2. Okay, we tried to solve equation 2 for y in terms of x. So doing that, transpose 2x to the right, y is equal to negative 2x. Okay. And if we try to substitute this y is equal to negative 2x in equation 1, so substitute y is negative 2x in 1, we have 5x plus 2y, substitute negative 2x plus z equals 0. We have 5x plus 2 times negative 2x, negative 4x plus z equals 0. 5x minus 4x, it's x plus z equals 0. Then if we try to solve for x in terms of z, you transpose the z to the right side. X is negative z. Okay? So, if we set a parameter, okay, let's say z is equal to t. Okay, t is a parameter. And substituting x is equal to negative z, which is now t, right? Okay. Then substituting y equal to negative 2 times x, which is x is now negative t. So we have y is equal to negative 2 times negative t or positive 2t. We created the parametric solution set of the linear equation, which is x is equal to negative t, y is equal to 2t, and z is equal to t, where t is any real number. So this is the solution set. And this will be infinitely many, right? Because you can assign any value of t here as long as this n real number. Let's say if t is 0, x is negative of 0, which is still 0. Y is 2 times t, 0, which is 0. And z is equal to t, 0. So one solution set is the coordinate 0, comma 0, comma 0. Also, if you want t equal 1, so x is negative 1, y is 2 times 1 or 2, and z is t, which is 1, or the coordinate negative 1, 2, comma 1. You can set another value of t, let's say 2, 3, 4, 5, and so on. So you will have another set of values for the solution. That's why we have infinitely many solutions, and the solution set can be written in this parametric form. So if you have a system of linear equations whose number of equation is less than the number of unknown, such as this problem, you can expect that you can have infinitely many solutions. Okay, next. Number 6. What if x plus y plus z equals 0, y equals 0? Again, this system of linear equation, so let's name this equation 1, this equation 2, has number of equations less than the number of unknowns because the number of unknowns are 3, x, y, z, but the number of equations are just 2, equation 1 and equation 2. So therefore, we can expect infinitely many solutions again, just like in previous problem. So notice that y has a fixed value, equation 2, y is 0. Therefore, if we substitute 2 in 1, so x plus y, which is 0, plus z equals 0, we can have x plus z equals 0. If we try to solve for x in terms of c, you transpose z to the right side, x is negative z. Okay, if you set z equal to t, which is the parameter again, therefore x can be equal to negative of z, but z is already equal to t. X can be equal to negative t. And y is fixed always at 0. So therefore, the solution set can be written as x is negative t, y is 0, and z is equal to t. Again, t is any real number. So the solution set is this one, which has infinitely many solutions if you assign any real number value for t here. Okay, next, 7. What if 3x plus 2y minus z equals 3? Okay, only this one. So we have 3 unknowns, x, y, and z, but there is only one equation. Okay, so you can expect again to have infinitely many solutions. So what we can do is, let's try to solve for x here in terms of the other two variables, y and z. So transpose this 2y and negative z to the right. We have 3x is equal to 3, then minus 2y plus z. Okay. Divide both sides by 3. so that x is, so you can divide each term on the numerator by 3. We will have 3 over 3 minus 2y over 3 plus z over 3. Or x is 3 over 3, 1 minus 2 thirds y plus 1 third z. This time, we can set two parameters. Okay? So, if we set, let's say, y is equal to s and z equal to t, therefore, x is 1 minus 2 thirds y, which is, you can now substitute as s, plus 1 third z, you can now substitute as t, right? So this is the value of x in terms of the parameter s and t. So the solution set can be x is equal to 1 minus 2 thirds s plus 1 third t, then y is s, z is t, where this time s and t are any real numbers. Okay, so you now have two parameters, s and t, which you can assign any real number value. So you have also infinitely many solutions. Okay. Okay, next, number 8. What if x minus 3y plus z equal to 1 and 2x minus y minus 2z equals to x plus 2y minus 3z equals negative 1. So you have equation 1, equation 2, equation 3. So this time, we have complete 3 linear equations and we also got 3 unknowns x, y, z. Okay, so let's do the usual method. Let's try to eliminate one variable at a time. So let's choose. What if this time, let's eliminate x first? Okay. Eliminate x first. So if we use equation 1 and 2, I can multiply equation 1 by negative 2 and add with equation 2 to eliminate the x. So, negative 2 times equation 1 plus equation 2, right? So, negative 2 times the equation 1, x minus 3y plus z equals 1. Distribute the negative 2. Negative 2 times x, negative 2x. Negative 2 times negative 3y, positive 6y. Then, negative 2 times z, negative 2z equals negative 2 times 1, negative 2. Okay. You can now add this to equation 2. 2x minus y minus 2z, 2z equals 2 because you can already eliminate the x. The coefficients of x are additive inverse of each other, negative 2 and 2. So negative 2x plus 2x, so 0. X is already eliminated. 6y plus negative y, positive 5y. Then negative 2z plus negative 2z, negative 4z equal to negative 2 plus 2, 0. Let's name this equation 4. Okay. Next. Okay, we can eliminate this time x using, let's try to use equation 1 and 3 because the coefficients are the same, both 1. If we subtract 1 minus 3, x will be eliminated. So 1 minus 3, okay, equation 1, let's copy. And then equation 2, 3, I mean copy. So subtract x minus x, 0. Negative 3y minus 2y, negative 5y. Z minus negative 3z, positive 4z, right? 1 minus negative 1, positive 2. Okay, let's name this equation 5. Okay, now, we have now we have equation 4 and 5 in two unknowns y and z only, right? So this is equation 4. Notice that we can add equation 5 and 4 to eliminate the y as well as the z. Oh. So adding equation 5 and 4, negative 5y plus 5y, 0y, right? So y is eliminated. 4z plus negative 4z, 0z. So z is also eliminated. So the left side turns out to be equal to 0 because both y and z are eliminated. How about the right side? 2 plus 0, which is 2. So the resulting equation is false because 0 is not equal to 2. It's actually should be written 0 not equal to 2, right? So since this is not true or false, it means that the system of linear equation is inconsistent. Okay? So you will say that the system of linear equations is inconsistent or has no solution. So once you encounter a false equation or statement, when you do elimination method along the steps like this, we encounter uh, an an expression that is not true or equation that is not really equal. The left and right side are not equal. It means that the system is inconsistent or it has no solutions. Okay. Next, number 9. Okay, what if y minus z equals 0, x minus 3z equals negative 1, and negative x plus 3y equals 1? So we have three equations, equation 1, equation 2, equation 3, in three unknowns, x, y, z. So we are complete. Okay. The number of unknowns conforms with the number of equations. So let's try to use elimination or substitution method. So from equation 1, we can solve for y in terms of c. So y minus z is equal to 0 in equation 1. If we try to transpose negative c to the right, we can solve for for y equal to z. Okay, let's name it equation 4. If we substitute 4 into, okay, we have x minus 3, but z is equal to y, so that x minus 3 times z can also be equal to x minus 3y. Substituting z here with y. Equal to negative 1. Okay, let's name this equation 5. So that we can use equation 3 and 5. Okay, if we add equation 5 plus 3, so this is equation 5. X minus 3y equals negative 1. And equation 3 is negative x plus 3y equals 1. So we can eliminate x, right? So x plus negative x, that's 0. So x is already eliminated. Negative 3y plus 3y, also 0, right? So both x and y this time are eliminated. Therefore, we are left with 0 on the right side. I mean on the left side. On the right side, negative 1 plus 1, 0. So it means that the resulting equation, 0 is equal to 0, is true. Meaning that the system is, or the system has infinitely many solutions. Okay? Many solutions. Because what we have here is a true statement that 0 is indeed equal to 0. Unlike on the previous problem, we had a false statement because 0 is not equal to 2. But this time, if you encounter this true equation or true statement, this means that the system of equations has infinitely many solutions. So you can represent the solution set in parametric form if you have systems of linear equation that has infinitely many solutions. Okay? So using the relationship that we got, equation for y is equal to z. Okay? And if we try to use equation 2 here, copy. If we try to solve for x here in equation 2, you just transpose negative 3z to the right side. So x is negative 1 plus 3z, or x is 3z minus 1. Now, if we assign a parameter again, let's say t, if we let z be equal to t, okay? Therefore, since y is equal to z and z is already equal to t, y is also equal to t, right? And from here, x is equal to negative 1, or let's use this na lang. So, x is 3z, but z is t. We can substitute z with t. So, x is 3t minus 1. So, this is the parametric solution set. X is equal to 3t minus 1, y is equal to t, and z is equal to t, where t is any real number. Okay, so that's why the solution set has infinitely many values. Okay, if you assign any real number value with t. Okay. Okay, so I think that's it for this topic. Solving system of linear equations, this time in 3 unknowns. Maybe if we have next part for this, I will try to solve system of linear equations in 4 unknowns. Let's say w, x, y, z using elimination and substitution method. Okay, and after that, we will try to use another method in solving systems of linear equation using matrices. Okay, so stay tuned for that. So you can also watch the previous video, the part 1 for the system of linear equations. I will just put the link on the description. And also, I can put the link of the Advanced Engineering Mathematics playlist so you can check it also. Okay, so I hope you learned something from this video and thank you for watching. See you on my next live. Bye-bye.